Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the previous video I started with the topic of filters. In that topic we covered one of the filter that is included in GATE syllabus, that was capacitive filter. So I told you the circuit works much like a clamper in which the capacitor gets charged to a maximum value of Vm, where Vm is the maximum value of supply voltage. And then we saw that the peak to peak ripple in such kind of filter was how much? Vm by FRC. So we saw that average voltage was maximum voltage minus peak to peak ripple by 2, and the minimum voltage was maximum voltage minus peak to peak ripple. Okay, we also saw that the ripple factor was 1 by 2 root 3 FRC. So I told you that it is inversely proportional to R. So R must be high in order to have better filtering or in order to have less ripple. So in this video we will see some more filters, but they are not included in the GATE syllabus. They are important only from ESE point of view. So the first filter that comes under this category is the inductive filter. So now if you see, I have a full wave rectifier at the output of which I have connected an inductor, and then there is the resistive load. So the output of full wave rectifier is something like this. This is the output of full wave rectifier. Now if you see, this is an even function. This is an even function and it has a frequency double of the supply frequency. So if it is an even function, that means, and it is periodic also. If even function is periodic, what I can say? That the Fourier series contains only cosine terms. Other thing is that it is even half wave symmetric. Even half wave symmetric means x of t plus t by 2 is x of t. So it will only have even harmonics. Okay, because if you consider 2 pi as the period, if we consider 2 pi as the period, then after pi we see that the function is repeating. The same thing that I am saying here. If period is 2 pi, then t by 2 is pi. If the function repeats after pi, then it is half wave symmetric, even half wave symmetric. So it will only have even harmonics. So what I am doing now is I am expressing this V01 in terms of Fourier series. In Fourier series, we will only have cosine terms, and that too even harmonics. But we will also have a DC term. DC means average. The average of this waveform is 2 Vm by pi. That is your DC term. Plus when we will talk about AC term, there will only be even harmonics. And if you derive, I am not deriving the Fourier series, I am directly writing k minus 1 k plus 1 pi cos k omega naught t. Okay, so these are the AC terms. Now if you see, if we talk about the kth harmonic, it is inversely proportional to k minus 1 k plus 1, which means as k increases, V01 k reduces. That is, as the order of harmonic is increasing, the magnitude of voltage is decreasing. So that means lower order harmonic, that is harmonics having lower value of K. Lower order of harmonics are more dominant. That is what I can say. So now if I want to write down the current, think like this. I have a DC and a AC term combined and I want to find out this current I. I want to find out this current. Now for DC, inductor is short. So IDC is simply VDC by R. But for AC, inductor becomes a reactance. So IAC is VAC by Z. That is impedance. Now Z for kth order harmonic will be R plus J K omega naught L. Are you getting my point? Because for kth order harmonic, the frequency will be K omega naught. So when you are finding the impedance, it will be K omega naught L. Is it fine? This can be written as mod ZK. Mod ZK is under root R square plus K omega naught L square. And its angle theta K will be tan inverse K omega naught L by R. Now RL load is considered to be a lagging load. If RL load is lagging, the current will lag behind the voltage, and by what angle will it lag? It will lag by an angle that I wrote here, theta K, tan inverse K omega naught L by R. So when you will write down I, in DC term we will only divide by resistance because inductor is short for DC. For AC, what I will do is I will divide by magnitude of impedance and then the function will lag the voltage by theta K. Okay, but as I have told you, now see, as K increases, K minus 1, K plus 1, this increases. Also mod ZK will increase, okay, because of this K. If mod ZK also increases, I'll say that IK reduces as K increases. That is why I'll only talk about the second harmonic. I'll not take higher order harmonic, because as the order of harmonic is increasing, the current for that harmonic is reducing. So now when I'll write down the current, I will ignore all the higher order harmonic and I'll only talk about which one? Second harmonic. So for Vm, K will be kept as 2. 2 minus 1 is 1. 2 plus 1 is 3. 4 Vm by 3 pi mod Z2 cos 2 omega naught t minus theta 2. That will be the current. In this, the DC current is actually 2 Vm by pi R, and the AC current, if we talk about RMS value of AC current, it is 4 Vm by 3 root 2 pi mod Z2. Okay. Now when we talk about the current ripple factor, or if we talk about ripple factor, it is the ratio of AC RMS value to the DC value. Vm will get cancelled. 4 by 3 root 2 pi mod Z2 upon 2 by pi R. So how much will it become? Root 2 by pi will also get cancelled. Root 2 by root 2 R by 3 mod Z2. Okay, this will become. Now Z2, mod Z2 is actually under root R square, K is 2. So 2 omega naught L square. Now this will be approximately 2 omega naught L, because 2 omega naught L is much greater than R. Okay. Because inductance is kept at a large value in order to reduce the ripple. So what you can say, that mod Z2 is how much? XL, where XL is 2 omega naught L. So how you will write gamma? Root 2R by 3 XL. Now if you see in this case, gamma is proportional to R, which means gamma is low if R is low. In capacitive filter, gamma C was 1 by 2 root 3 FRC. So I told, in order to reduce the ripple, you have to increase the value of R, and here in order to reduce the ripple, you have to reduce the value of R. So what you can say, for low value of resistance, inductive filter is preferable, and for high value of resistance, capacitive filter is preferable. We move to the combination of the two filter called as LC filter. So we have seen in inductor, gamma is proportional to R. In capacitor, gamma is inversely proportional to R. So what I can say, gamma LC is independent of R. If gamma LC is independent of R, I can say LC filter is an universal filter. That is, it can be used at any value of resistance. It is not necessary to have high or the low value of resistance. Just now I told in V01 Fourier series, what we were doing is we were ignoring the higher order harmonic and only considering the third harmonic. Sorry, second harmonic. Because at higher order the harmonics are very less. Okay. Now if we talk about DC voltage, in DC voltage, inductor can be shorted and capacitor can be open. If inductor is short and capacitor is open, then this circuit will be somewhat like this, which means for DC, V01 will be same as V0. So V0 DC is same as V01 DC. Okay, that is for the case of DC. So how much will it come out to be? 2 Vm by pi. But for AC, first I will need Z equivalent. Z equivalent is inductor is connected in series with the parallel combination of resistance and capacitance. Now this parallel combination plus series combination is approximately J 2 omega naught L, which I call as JXL. Okay. This series inductor value is much higher than the parallel combination of R and C. So that way, if I talk about AC current, how you will write down? Vm by 3 pi XL, okay, into cos 2 omega naught T minus 90. Okay, that will be the AC current. Now once I have this AC current, this is the current I whose AC component I am talking about. Once I have the current, I can find out the voltage. So what I'll say, V0 AC is IAC into resistance with resistance in parallel with C. Okay, that I can say. Now once I know that resistance in parallel with C, here we know capacitance value is, or capacitance value is high, which means 1 by 2 omega naught C is low. If this is low, the parallel combination will be approximately 1 by J 2 omega naught C. So IAC by J 2 omega naught C, or you can say IAC by J into XC. Okay. So when we talk about V0 AC, so what was the AC current? 4 Vm by 3 pi XL. Now it will be multiplied by xc. I'm not talking about the angle, so that is why I have ignored this j. So if you see, the peak value of current was 4 Vm by 3 pi XL. Now if you say V0 AC RMS, for RMS what you will do? 4 Vm by 3 root 2 pi into XC by XL. Okay, that will be V0 AC RMS. And we have already derived V0 DC is 2 Vm by pi. Again, if we want to talk about the ripple factor, the ripple factor is how much? V0 AC RMS, that is AC RMS by DC voltage. Vm will get cancelled, pi will also get cancelled. So 2 by 3 root 2 XC by XL, or you can say root 2 by 3 XC upon XL. As you can see, this factor is independent of R, and hence LC filter can be used at high as well as low value of resistances. So here I have just used basic network analysis, and I have assumed that higher order harmonics are very low. If they are very low, I am only considering the dominant harmonic or the second harmonic. Now if you want to further reduce the ripple, what you can do is, you can divide LC filter into multiple sections like this. It is called as multi-section filter. Okay. So these terminals will be grounded. So instead of using a combination of one L and C, we can have multiple inductors and capacitors. If we have n sections, gamma will be root 2 by 3 XC upon XL to the power n. But what happens? Each inductor has internal resistance. Now earlier I told you for DC, inductor is short, capacitor is open. But if each inductor will have a resistance, for DC it will not be short, for DC resistance will be present. If resistance is present, it will cause a voltage drop. If across inductor due to resistance there is some voltage drop, so what will happen is V0 DC will reduce. So if we increase the number of sections, then we can reduce the ripple, but at the same time, due to internal resistance of the inductor, there is voltage drop and the output DC voltage reduces. Next, let us come to the CLC filter. So CLC filter is made of two filters. One is the capacitive filter and other is the LC filter. Now here we know that the average output V average, for capacitive filter we know V average is Vm minus Vm by 2FRC, and for average inductor is short and capacitor is open, so you can say that V0 average will also be same, Vm minus Vm by 2FRC. In such kind of circuit, what happens? The gamma value is root 2 XC1 XC2 by XL into RL. So here again, as you can see, gamma is inversely proportional to RL, hence it is suitable for large value of RL. But again, gamma of CLC is less than gamma of LC. So CLC filter is better than LC filter. We want ripple factor to be 0. So the smaller the ripple factor, the better it is for us. Here XL is omega L, XC1 is 1 by omega C1, XC2 is 1 by omega C2. Where omega due to full wave rectifier is 2 omega S, for half wave rectifier, omega will be equal to omega s. Because we know in full wave rectifier, the frequency becomes double. Okay. A variation of CLC filter is called as CRC filter. Now here what we do, if I naught is small, I naught is load current. If load current is small or the ripple in the load is small, then we can replace inductor by a resistor. See, inductor is used to smoothen the current waveform. Okay, inductor is used to smoothen the current waveform. That is why if current value is very less, we can replace that inductor by resistance. But for high values of current, inductor becomes necessary. Now when you are replacing inductor by resistor, you have to make sure that XL is equal to R. That is why gamma of CRC will be root 2 XC1 XC2 by RL into R. So R replaces the value XL, and where it will be used? When the load current is small, because then inductor might not be required. Moving to the last concept related to filter, we talk about bleeder resistance. Bleeder resistance is this RB. Now as we know, in a filter, capacitor gets charged. So when you turn off the supply, when we turn off the supply, then this charge remains on capacitor. If the charge remains on capacitor, it can be a shock to the user, to the person or the operator who is operating this circuit. It can give a shock. So we want to give a discharge path to the capacitor. So bleeder resistance is used to discharge capacitor in absence of supply. But now, if capacitor works like a clamper and you are providing a discharge path, then the capacitor voltage will not remain constant and capacitor can discharge through this resistance. But we don't want that to happen. That is, under normal operating condition, we don't want bleeder resistance to have any effect. Otherwise, capacitor will discharge and V0 will not be constant. We want this V0 to be constant, so capacitor should not discharge through RB. That is why RB is very high. It is so high that it can only carry IRB max is 10% of load current, or you can say RB is 10 times load resistance. If RB is 10 times the load resistance, its current would be 1 by 10 times, or you can say 10% of the load current. So we connect a high resistance, otherwise it will affect the normal operation of the filter. So we connect a very high resistance, but what is the use of this resistance? That when the circuit is not working, it will discharge the capacitor for the purpose of safety. So in bleeder resistance, you just need to remember the purpose for which bleeder resistance is connected. Nothing more will be asked about this. So if we summarize what we have learnt in this lecture, we saw that the gamma of L filter was root 2 by 3 R by XL. Okay, that was the gamma of L filter. Then we saw gamma of LC was root 2 by 3 XC by XL. And for multiple section inside the filter, gamma is root 2 by 3 XC by XL to the power n. Then we saw in a CLC filter, gamma is root 2 XC1 XC2 RL into XL, and in CRC root 2 XC1 XC2 RL into R. So XL is replaced by a resistance R in case of a CRC type of filter. Okay, so that is what we have learnt in this lecture. And if you are appearing for ESE, then only these concepts are important. Otherwise you can leave these concepts, they will not be asked in GATE. Okay, so that is all about the different type of filter that can be connected with a diode, circuit or rectifier. Thank you.
I hope all of you have enjoyed the lecture that we were providing and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250. With code Ankit ESE it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live you will get the notification. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, GATE Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.